Nutanix Enterprise AI offers an enterprise-grade platform for LLM and API management and monitoring. But what does this really mean in the context of real-world AI applications? Hi, I'm Laura Giordana, Technical Marketing at Nutanix, and today I want to walk you through a real-world AI RAG application that enables you to chat with your own documents and data securely. Let's dive in. So let's start by defining what RAG is. Now, if you're already familiar with RAG, feel free to skip to the demo chapter by selecting the timestamp in the description. But if the only RAG you know is the one you use to clean your house with, then this quick primer might help. RAG stands for Retrieval Augmented Generation and enables LLMs to incorporate new information without altering the LLM itself. So that means you don't need to fine-tune or custom train your own model. So what does this look like? If we look at a simple chatbot application where you simply ask a question and receive an answer from an LLM, what this looks like on the back end, for example, is you'll have the chatbot application running. We have the LLM running, hosted on Nutanix Enterprise AI and living on an NFS share. In this case, we're running everything on Nutanix. The chatbot user will come in and ask a question, such as help me plan a trip to Paris. The chatbot application will query the text generation endpoint directly, return an answer, and then return that back to the user. But now, if the user wants to ask a question specific to the organization, such as what is the time off policy, depending on the endpoint, it's either going to say it doesn't know, or it's going to give some generic answer that's not specific to your company policies. So before we show how this looks like with retrieval augmented generation, there is a concept we should understand first, and this is around embeddings and embedding models. So what an embedding is a numerical representation of objects for use in machine learning systems that are able to retain their semantic value. So this enables applications to understand the relationship between two pieces of data so that they can calculate the similarity between the two. Now, there are many pre-trained embedding models that can help us do this translation from text to an embedding vector. These models have learned from a huge amount of text and so understand how words are normally used and which context these words are used in. So let's take a look at a quick example. So in this case, using a multi-dimensional vector with 768 dimensions, we feed our objects into the embedding model and it produces a vector based on that string. And then the application is able to do distance calculations to understand similarity. So the shorter the distance between two items, the lower the score. That means the more similar they are. So for example, it may group fruits, tech concepts, weather, those types of things together. Looking at this with a partial code sample using LangChain, we can embed a few pieces of text and see the partial vectors that are being generated. We're just looking at the first three dimensions, but we can see what that kind of looks like. And then using an evaluator to calculate the distance, we can evaluate what the distance is between two strings. So for example, apple and pear are relatively close together compared to something like pear and computer or banana and computer. You may be thinking, what if I put apple and computer in there? These will actually relate closely because of the brand, which is why further context would be needed to appropriately evaluate the strings. For example, you would want to compare eating an apple to computer, which would result in a longer distance. But this is typically what the application itself will be doing on the back end. And this is just for you to understand the concepts of how embeddings and embedding models work. So with that in mind, now to enhance our chatbot with retrieval augmented generation, it would look something like this. So we have those same components we saw in the first diagram where we have our LLM endpoint, we have our chatbot, and our model is hosted on our NFS share. But now we're expanding this. So we're introducing an object store where we have our company documents uploaded to a bucket. We're adding in a vector database that is going to store all the vectors from these documents. And what will happen now, we also have an embedding model. So we're hosting an embedding model on Nutanix Enterprise AI alongside that text model. So now what happens is when the user asks a question specific to their company or any question, before going directly to the text LLM endpoint, it's going to first query the embedding endpoint. It's going to embed the prompt, and then it's going to compare that vector with vectors in the database to find similar embeddings. And then what it's going to do is it's going to go ahead and augment the prompt with the context that it found in the database, and then it will return a much more specific and accurate answer. Now, this is just one simple example of a retrieval augmented generation pipeline. You could also, of course, incorporate things like re-ranker models to improve the quality of search results, safety models to maintain security and compliance, or incorporate tool calling for agentic workflows. Now, let's jump into a demo of what this would look like. So if you watched the retrieval augmented generation intro, this will look very similar to what we just saw. So what we have here is Nutanix Kubernetes platform running on Nutanix Cloud Platform with Nutanix Enterprise AI hosting our LLM endpoints that our application chatbot can query. We're also using Nutanix files to host the models, as well as Nutanix objects to host buckets for our vector database and user data. In our demo, we're using Nutanix Database Service to host our Postgres PG vector database, and we're also adding in a second application, which is an observability tool for our AI admin to get a deeper dive on things like the LLM metrics and prompt tracing. And we'll also be leveraging a third endpoint in our application, which is a guardrail safety model. The applications we'll be using are open source Kubernetes applications called Flowise and Langfuse that can run on NKP. And so this demo will show how you can build, deploy, and monitor an AI chatbot using your own documents and data, all contained within your own sovereign cloud platform. Let's start with a quick overview of Nutanix Enterprise AI. As an admin user, you have global visibility into all of the endpoints deployed on the system, the API request trends, the top 5 endpoints and API keys being used, as well as your infrastructure usage and health, so you can drill into the resource utilization of the underlying Kubernetes cluster, including GPU utilization. As an admin, you also have full visibility into all of the models and endpoints that have been deployed on the system by various users, and also all of the events that have occurred on the system, for example, users logging in and out or creating and deleting models and endpoints. Admins can also create and manage users with either the admin or user role. And the first thing we need to do to import an LLM is add in the necessary credentials for the model repos we want to use. So this would be your token and Hugging Face and or your NVIDIA NGC personal key if you wanted to download NIMs. For Hugging Face, be sure to also ensure that your account has access to the model. Next, we can import a model in just a few clicks. You can import models from Hugging Face, NVIDIA NGC, or manually import your own custom model. You can choose from popular pre-validated models, including text generation, re-ranker, embedding, reasoning, and safety models, with new models being added regularly. In this demo, we'll import the Llama 318B Instruct NIM, and all we have to do is select it, give it a name, and then the system will begin the process of downloading the model. When the model is marked as active, we can then create an endpoint for it. When creating an endpoint, you'll give the endpoint a name, select the model to use, define the number of instances that we want to use, and then configure one or more API keys for applications to connect to the endpoint. Pre-validated models like this one include pre-configured recommendations for compute resources, taking the guesswork out of model deployment. The endpoint will take a few minutes to spin up and remain in a pending state until it's ready to go. We can see we have several active endpoints on our system, so let's take a look at one of these. Drilling into the endpoint, we can see the endpoint dashboard, where metrics will populate as the endpoint is used. You can also test endpoints directly from the interface, so you can be confident your endpoint is working before handing it over to your application developer. You can also view sample code and include tool calling constructs in the code as well. Now let's go ahead and see how we can use this and other endpoints in a real application. So looking at our endpoint list, we'll be using the Llama 318B Instruct text generation model, the NemoGuard safety model, as well as an embedding model in our application. We're using an open source low-code tool called Flowise that enables developers to build custom LLM orchestration flows and AI agents. It's a Kubernetes application that you can easily install on NKP or the Kubernetes platform of your choice. We've set up a flow to create an end-to-end AI workflow using nodes. A node in Flowise is a component that performs a specific function in our workflow. The core of our flow is based on this conversational retrieval QA chain, which is based on LangChain and connects different nodes together to build a retrieval-based question answering chain. It's connected to an NVIDIA NIM chat model node, which is a wrapper around the NIM inference API, which is connected to our model that we saw in Nutanix Enterprise AI. For Hugging Face models, you would use the generic OpenAI node, as Nutanix Enterprise AI endpoints are OpenAI compliant. We're also using the document store vector node, where we have a document store configured. A document store is where we'll configure everything related to data management, including our embedding model, vector database, and object store. A document store leverages a document loader, which lets you load documents from different sources. Here, we're using the S3 directory loader to connect to our S3 bucket hosted on Nutanix objects. So jumping into Nutanix objects, we can view and manage the bucket we're configuring here. And the document loader is also configured with our embedding model hosted on Nutanix Enterprise AI. So that's the second model that we're using. It's also configured with our Postgres database running on Nutanix Database Service with the PG Vector extension, as well as the record manager to keep track of indexed documents. So jumping into NDB, we can see our database managed by Nutanix Database Service, and we can also verify connection to the database and view our embeddings of our existing documents. Lastly, we've also implemented input moderation using our third model, the NEMO Guardrails model, hosted on Nutanix Enterprise AI, and this is connected to the simple prompt moderation node in Flowise. So we can test out our chatbot here, or we can share it externally. Our chatbot is currently configured to only answer from the provided context. So if we ask a question that it doesn't have the context for, it will reply with a generic answer. Let's upload a document to help it out. Once we've uploaded the document, we'll come back into Flowise and process the document so that Flowise will break up our new document into chunks for embedding and adding into the database. This can, of course, also be automated. So upserting the data will embed our new document chunks and add it into the configured vector database. And then going back into our chatbot, we can then ask the question again, and we can see it's now able to provide us a more relevant answer based on the document we uploaded, and we can also see the source of where it got that answer. We're also running Langfuse on Nutanix Kubernetes platform, which is an open source LLM observability platform. Langfuse enables tracing, monitoring, and observability of LLMs, and Flowise can be configured to integrate directly with it. Langfuse enables you to get detailed information on the latency, token count, prompt information, and much more. So this is just one example of how you can easily deploy and run solutions on Nutanix that enable you to chat with your own documents and data and debug and trace LLMs. And the best part is, all of the documents, models, and data are stored securely on the Nutanix Cloud Platform, ensuring that your company proprietary data remains private, secure, and under your control. For more information, check out our other videos in the AI on Nutanix playlist and be sure to take a test drive. We'll see you in the next video.